Hello, Cryosphere. So, we're back with another Winter Blue Ocean update. It's the first one in May. It will be exciting. In the Winter Blue Ocean updates, we look for when we will have the first year with no Arctic sea ice up here in the Arctic Ocean. And this time it's the annual average extent that has gone up to 9.72 million square kilometers for annual average extent. And what's extraordinary here is actually that for once these graphs are going up, you know, and you can actually only with two prior years, 2013 and 2016, you can sort of get a picture of why that is, because some of you may know that last year in April and May was the record low year for about 2 or 3 months. So when the annual extent is calculated based on the difference between this year and last year, if we are not completely as low in the daily extent as 2016 was in May, then we will go up. And a lot of people are worried that it has to be wrong because we cannot have ice going up in April, May, and June. Well, it's a 365-day average. So if that average is increasing, then the graph will go up. So the reason we go up is more or less last year, that 2016 was so extraordinarily low, and you can see the only month in recent years when we have gone up as much as we've done now is back in 2013, December 30, 2013. We went up even more, and the graph for 2013 is here. So the big question is 2017 going to be another year like 2013, where you start lowest ever like this, and then you come to about April, May, and it starts going up, and it finishes, like 7th or 8th lowest by the end of the year. That could happen, but we could also, turn over and start going down again. It's not. It's the Arctic. It's not very predictable. So yeah, you have the same kind of mechanism in 2013 that you had. 2012 was the prior year, and that was of course also record low. So that's part of the reason why 2013 went up, but it was also more cloudy because of all the open water in winter and spring. So yeah, and in the next slide you can see here you have 5 years in each color. You can see there is a certain periodicity where it seems to be a pattern that is repeating every 5 years. But that doesn't have to be significant. But there's been some debate and some expectation that maybe 2017 would start another one of these wavy patterns here. Like 2007 and 2012, they had this wave top here and then steep decline here in the summer and autumn. So But as I said, this is the Arctic, so we have no idea what's going to happen. And every melt season is very, very different from the others. But here's 2017 anyway. It's been kind of uneventful, pretty flat. But now you can see, as in the former slide, it's going up here in the latest month. So it could be going up to a wave top and then going down, we don't know. So for me, one of the reasons I don't think we will see another 5-year pattern like this is that I think we are now at the lowest ever for the annual average extent. I think we will go too low in a way. So in the daily extent for the summer and autumn, we will go too low for this pattern to repeat, I think, because you get to a point where there's too much open water and you get very, very strong feedback mechanisms because of the open water, with more water vapor and more storms and low pressure cyclones coming up in the Arctic, and with the loss of inversion of the air layers over the Arctic, more waves and swells, and so it could actually just go down, more or less go straight down in all of the coming years. But we'll have to see. So in this next slide you have this is a glacier lake, and then you have different projections from this same app since last autumn. And the new thing here now is that you have the never projection. That is because the graph is going up for the first time, and of course if you project that rising graph into the future, it will never reach 0. That's pretty obvious. But you also have a lot of other prior projections that did not say never, and the most common one is that we will lose all Arctic sea ice all year in 2021. And the second most often is 2023. And the decade which is projected most often is the 2020s, of course. 2030s in number 2. But all of these are based on really, really short time periods. And we have longer periods in the next slide. In this graph you have the 1 to 3 year current volume losses of Arctic sea ice. So that's the losses you've had over the last 3 years since May 2014, for instance. And that loss, if projected in a linear fashion into the future, you will have no sea ice for the whole year in 2029. And for the 2-year trend, it's 2024, and the 1 year is 2025. And I would change this graph so that now you can see the half-year trend, which is reacting quicker to the changes in the Arctic. That is now in a black color. And you can see that in the latest months we've had a slower decline of Arctic sea ice volume. And that means that this plot believes we will lose the all-year ice later, currently by 2029. So that the black one will go more up and down in a wavy pattern, while the blue graph area, the blue field, is going to be more steady, a bit more steady than the black one anyway. And the long-term trends are pointing to 2024 to 29 for all sea ice loss. So we go to the next slide. Here you have volume on the left and extent on the right. And 24 to 29, that is down here, based on the past 1, 2, and 3 years. For no sea ice at all. And the green trend line into the future goes to 0 in 2034, and that's based on all the years back to 1979. And you also see we have the annual average volume graph is going fast down towards the trend line, and will dip below it, probably during the summer. So yeah, and the for the short-term predictions, 2021 is the most often projected. That's over here. But it's probably more likely that the longer-term projections for 25 to 29 will be more accurate. If nothing happens, they are based on a linear decline. But it could decline in an accelerating manner, bringing us closer to 2020. On the right you have extent, and as with the very first plot I showed you, this red graph is flattening out and going up again. So this will also go never to zero, if the short-term trend is prevailing, which it will very likely not. But the middle, the green trend line here, the linear one, is going down to zero, in the 2200s, about 200 years from now. And but the volume is kind of, volume is king. The sea ice volume is deciding how high the extent is allowed to stay, because when you lose all volume, you don't have any sea ice, and then you don't have any surface sea ice extent for the satellites to look at. All right, final slide. So we are in the mid of May, and big areas are opening up along the shores of the Arctic Ocean, along Alaska coast and eastern Siberian coast, and we are approaching peak insolation, peak sunlight heating season, and we will have a big warming up of the open ocean parts, and we'll see how fast this melting season is going ahead. And the big sort of joker or a wild card in the Arctic Ocean is, of course, the methane molecule, the frozen methane on the seabed in the eastern Siberian Arctic shelf. And we'll see what happens to that as well over the summer. Okay. Thank you for now. Bye.